All right, there are two questions on 17A that are circled that we're going to go over, and then we're going to talk about some stuff that's review for the test. Whoa, I don't know what I just did. What's new? I never know what I just did, right? What's wrong? We good?
Yeah, we're good.
All right, number 4. We talked about solving rational equations, but it hasn't been an assessment yet. So I wanted to review this real quick. What do we do to solve this? What? Okay. What would the common denominator be? X and x minus 4, right? So what I'm going to do is I'm going to take each of these terms and multiply by that common denominator. So here I'll multiply x and x minus 4 by this term. This one gets an x and an x minus 4. And this one gets an x and an x minus 4. So what happens to the left-hand side? The denominator cancels and we have 1. Here the x cancels and we end up with an x plus 5 times an x minus 4. Everybody okay? And over here the x cancels as well. This one's a little icky though, because why? Anybody know what's going to be tricky? At some point we got to distribute this negative, okay? All right, so if we FOIL this together, what do we get?
X squared plus x.
Okay, because we get a plus 5x and a minus 4x, so we get a plus 1x.
Minus
20. All right, and over here, when we FOIL these together, we get x squared minus 1 and minus 4 is minus 5x. Negative 1 times negative 4 is plus 4. Okay. So we get 1 equals x squared plus x minus 20. But what happens over here?
all the signs split.
Yeah, this is minus all of those, minus the product of those. So it's minus x squared plus 5x minus 4. Okay, do some simplifying. Happy days, right? We get rid of those. Add 1, we get 25, divide by 6, I get 25 sixths. Okay. You do have to check for extraneous solutions here, but what basically x could not equal what? Because we add 1 over here and get 20, okay. X can't be 0 or 4, right? In these kind of situations where we've just multiplied through by a common denominator, that's really the only thing that's going to affect whether it works is the factors that make the denominator 0. Okay? We'll talk about one in a minute where we square both sides, and that's a whole other situation. There are frequently things that don't check. All right, number 6 is very similar, so I'm going to go kind of quickly, but I had circled it on your paper saying I'd help you with this one because it's ugly. We factor this, and what will the common denominator be this time? A b and a b plus 4, is that what I heard? Oh, this one has a minus, doesn't it? Minus again. I'm going to write this over here. Okay, now I'm multiplying each by a b and a b plus 4. Okay. I know some of you skipped this step of writing it out. That's great. I'm just trying to make sure everybody knows what's happening. So here both cancel. We just end up with the numerator 4b squared minus 20b minus 24. What happens here? The b plus 4 cancels. So we need to distribute what here?
The B. Negative.
Yeah, if we do this all at once, we're going to distribute a negative b to both of those. So we're going to get a negative 4b squared and negative b times negative 24b plus 24b. You could distribute just the b and then remember to change the signs. Yeah, leave it in parentheses till you change the sign. Yep. And here the b plus 4 cancels, so what do we end up with on the right side?
B.
Just a 1b, yep. All right, do some algebra.
4B squared.
Okay. We had a really hard time all day with this question. What's the answer? So we get 8. Everybody okay?
Why is there so much trouble?
I don't know, because they just couldn't solve that when they got to the end all day.
Some difficulties yesterday, I think it was.
Oh. All right.
That was
We could put this back in, but what are the two numbers that wouldn't check, guys?
4 and 0.
Yep, negative 4 or 0, so we should be fine. Okay. I'm going to go with we're fine so we don't use up our time. Does that sound okay? All right. On the back, there are 2 questions that I wanted to talk about in regards to graphing, because these questions, they both have a hole in the graph, and I feel like we hadn't done enough examples where there was a hole, okay? And I think there's a hole on the test. That being said, these 2 are probably trickier than the ones on the test, okay? Because you have to do long division or synthetic division on these 2, and I don't know that you do on the test. All right. Number 7. What's the first thing you should do when you see one of these graphies?
Cry.
Yeah, factor everything. Yeah, cry and then factor. Okay, so final factor of the top, final factored form. Okay. And the denominator? Okay. Did I lose anybody on the factoring? Okay. The thing we need to be careful of, there's 3 things, okay? When you see that there's a hole, you have to still include the domain restrictions. So the domain is not going to equal what 2 things here? X cannot equal, negative 2 or negative 4. Okay? That's the first thing. The second thing is, if there's a hole at a particular point, there's not a vertical asymptote at that same point. So the next thing it's probably going to ask you is vertical asymptote, and then it's going to ask about any holes. I usually, so that I don't get confused, I do the hole first. I go, yeah, there's a hole when x is negative 2, so it's going to be negative 2 something. And then I just get rid of this because then I'm not confused. Does that seem okay? Once I've admitted there's a hole there, there's no longer a vertical asymptote there, so what's going on? Where is there a vertical asymptote? Okay? So again, my 3 things where you got to do the domain restriction. If there's a hole, there's not a vertical asymptote. And then you can cancel it to find the hole. Actual ordered pair for the hole. You don't have to do this, but it helps in graphing a lot. Once you've canceled it, now we can put a negative 2 in. If we'd put a negative 2 in back here, we'd get 0 over 0. Okay? But now that we've reduced it, we can put a negative 2 in. Yes, you get 2 over 2, which is 1. Okay? So the hole is at negative 2, positive 1. On the test, if you don't want to plug it back in and find the actual ordered pair, what you would do is you just know that it's at negative 2. After you get everything graphed, then wherever your graph is at negative 2, you just put a big old hole there. Okay? Make sure you do that, though, because it's part of the graph that should be shown. All right. Vertical asymptote at negative 4. Let's see how badly I can draw that.
That looks pretty good.
I'll give myself a A minus for that straight line. Okay. What about intercepts?
That would be -1,
0,
0.
0, and -1, 0. Okay. 0, right? This plain old x makes 0 an x-intercept.
Yeah.
Now, if it's already going through 0, 0, do we know the y-intercept already? That is the y-intercept, right? Otherwise, if you plugged a 0 in here, you'd get 0 times 1 divided by 4, which is 0. Okay. What do we got left? End behavior or horizontal asymptote? This is top heavy. So what's the rule? Nope. Bottom heavy is y equals 0. Equal weight is leading coefficient over leading coefficient. There is not a horizontal asymptote. There is an end behavior equation we have to divide. Now, if we're going to do long division, you could actually FOIL this x back through here and do synthetic division. Okay, and I'll do that on the next one. How's that? But let's do long division once. X squared plus 6x plus 8. Somebody remind me what the other one said. X cubed plus... That was it? Okay. Here we go. X squared to make an x cubed multiplied by exactly an x. You distribute through all three of those terms. Those of you who still don't get this long division thing, I'm losing patience. Okay, distribute x cubed plus 6x squared plus 8x. Then we're supposed to subtract. Any kind of long division you have to subtract, which changes the signs. Then we get a negative 3x squared, a minus 6x plus nothing for the constant term, right? Are we done, or can we do one more? We can keep going. What do we multiply this by to get exactly negative 3x squared? And then you distribute that negative 3 to all three of those. Negative 3x squared minus 18x minus 24. Change signs, add, do we care? Okay, if this was a long division question on the test, we would want to get, I think it's 12x plus 24. And just to clarify for the test, you would write x minus 3 was our answer, plus there's a 12x plus 24 that still has a divisor of x squared plus 6x plus 8. It's the remainder over this guy. All right, all we care about, though, we didn't care about any of that. After we knew there was a remainder, we could throw it all away. That's what it says on the green sheet. Because the end behavior equation is what? Y equals x minus 3. Okay, can you graph that accurately? Please tell me you can. Crosses at negative 3, has a positive 1 slope. Yes, I'm cheating. There's no way I'll draw that line accurately. Okay. The struggle with this question, if you go back to the original one and you type in this mess with parentheses divided by this mess with parentheses, you get this. And that's all you see in the window, negative 10 to 10, negative 10 to 10. There has to be another piece. If there's a vertical asymptote, there has to be something on both sides. Okay? Yeah, if you change your window to negative 20, your y window to negative 20, you get this piece down here. I promise you don't have a crazy window to find on the test, okay? You can see it in the standard window. You may need to move your window around a little bit to figure out all the pieces, look at your table for some ordered pairs if you're confused, but it's not going to be totally off. Okay, these just aren't very nice ones. One more? Maybe? Just to make sure we got this cemented in our brain. This one factors x minus 2 and x minus 1, I think. I'm trying to skip some. Is that working, guys? Okay, somebody check me. I'm just trying to get us moving a little faster here. All right, what can you tell me? Anything. I'll go in any order you tell me.
There is a vertical asymptote at x equals 0 and x equals 4. There's a hole at x equals 0.
Okay. I was just writing down if she's checking. Yes, we could change this to domain and say cannot equal 0 or 4. But the actual only vertical asymptote is at 4 because this is a common factor, so there's a hole at x equals 0. Once I've written that down, what can I do? Well, I can divide that out, right? Get rid of it, factor it out, and I'd get negative 2 times negative, I'm putting in a 0. I get 2 over negative 4, which is negative 1/2. So down here somewhere, I like to make my holes nice and big so I can see them after I'm done. We would be having glasses issues today. So. Vertical asymptote at x equals 4. That's a B. That's not a very good line. All right. What else? Intercepts? 1, 0, and 2, 0. If we plug in a 0, what happened? We get an undefined place. So there is no y-intercept. It's got a hole on the y-axis. Okay? End behavior. Remember I promised a minute ago I show you the shorter one. If we cancel this out, we could actually do synthetic division now. You just FOIL those back together, which was x squared minus 3x plus 2, because it's what we got when we just took the x out. Okay? Yes, Tyseer. Okay? The common factor of x here gave us the 0. Then we divide that out. Okay? This is what's left. This is our reduced fraction. And we put the 0 in for all the x's. So we get 0 minus 2 was negative 2. 0 minus 1 was negative 1. 0 minus 4 was negative 4. This became 2 over negative 4, which reduced to negative 1/2. Okay? So we put the x value where the hole existed back in, but you have to do it in the reduced fraction. All right. So if we FOIL that back together, then we could do synthetic division or long division like this. Okay, in the reduced fraction, which means our synthetic division would go 4, 1, negative 3, 2. Does this sound more fun? Did you say no? You don't like synthetic division, or just nothing about this is fun? I gotcha. I agree. That one wasn't too bad. What's the end behavior? How did I know that I had to divide? How did I know I needed to divide at all? Okay, was top heavy. And what's our end behavior?
X plus 1 equals y.
So, cheating once again, it crosses at positive 1. Yep. Okay, or not. I can't even cheat well. And goes up by 1 and over 1.
Good point, Kate.
That line doesn't look very straight to me, but I did my best. Okay. We also had 1, 0, and 2, 0. So what the graph is actually doing, it's down here this time, coming through here, turning around and going like this.
Beautiful.
And then there's a little piece up here, which you might actually see a little bit of this time if you did the original divided by the original. Okay. You don't have to know how to do that without your calculator. Get to use your calculator, okay? I'm just doing it quickly so that we can move on. Everybody all right? Did anybody have another question on either worksheet 16 or 17? Or 15A? Yes, Morgan?
On 16B, how do you do number 3?
Okay, it's going to take just a second to open. I'm going to do some questions from the chapter review, which you may want to write down. If you end up having to retake this test, you will need to do the review assignment that's on the gold sheet. Okay, and I apologize that it's yellow this time. We're out of gold paper, so I was trying to get a trend going, and it didn't work out so well. I'm also going to put some questions up today that are things that are on the test that maybe aren't on the review. So you might want to take a screenshot of those when we get there, okay? All right, well, that was opening. Which one, Morgan?
On 16B, number 3.
Whoop, whoop.
Whoa.
Don't move that. 16B. Oh, this has ink on it already. Okay, which one? This one? Okay, let's get rid of all this and talk about this. Oh, did it have flowers by it? Okay. That meant that it might be a test question. This number 3 is kind of icky, but it's doable, honestly. If you have a 0 at I, what else has to be a 0, guys? Yeah, because that's like a 0 plus 1i, so 0 minus 1i has to be conjugate pairs. Remember that part? Okay. So if 2i is a 0, then 0 minus 2i, or just negative 2i, is also a 0. All right, now we got 4 of them to worry about. If we did x minus the positive I, x minus the negative I, which would become plus, x minus the 2i, and x minus the negative 2i, because it's always minus, it would become plus 2i. Now this is not really as bad as it looks, because what is this FOIL together to make? Right. So that's an x squared plus 1, right? And these two FOIL together to make which is plus 4. And then we just need to FOIL these together. Which is choice C. Now, that's not on the test, but it wasn't as bad as you thought, right? The concept is on the test. There's not one where I'm going to make you FOIL it all out like that. Is that better? Yeah. Yes. If this was a question on the test, the first thing it would probably ask, what are all possible rational roots?
Oh, that's the last.
Factors of this over factors of the leading coefficient. Now, that's not very helpful because all of those choices are still there, right? Can't eliminate anything. Okay. We can, yes, we're going to graph it. That's what we're all going to do. But I want to talk for a second about the remainder theorem because that's important today for the test on Friday. The remainder theorem said if we want to know if 1 is a 0, we can plug 1 in because whatever we get out is the remainder. So what would tell us if it actually was a factor would be if we get out a remainder of 0. So if we wanted to know if this checked without actually going to our calculator, we just plug the 1 in. Does that make sense, guys? We're just plugging it in to see if it makes it 0, right? So you'd have 1 plus 3 is 4, minus 6 would be negative. I don't think it works. Negative 1 plus 3 plus 6 minus 8. I think that one actually works. Did anybody graph it? Yes? And it works? Okay. But what I would have done is just graph it. Is everybody okay now what you would have done to attack that problem? Okay.
But that's something we could possibly do like on that multiple choice question, or just have like.
Yes. I will show you a question that's more like the test and where it says use factor theorem in just, or remainder theorem in just a second. Morgan, did you have anything else? Yep. All right, I'm going to move back to the review questions here. A couple are just quick vocabulary. Everybody remembers what a polynomial function looks like? Okay, something crazy like that? That's a polynomial function. What is the degree of that one? So the maximum number of zeros would also equal that degree, which would be 3. And the maximum number of turning points would be 2 and minus 1. All right. If you had something in factored form, what is this multiplicity telling you? The graph bounces off the x-axis at -5. Good job. All right. This is where it talks about the remainder theorem. And instead of wasting time just yakking at you, let me go to the example I put on here, okay? Yakking. Here we go. This is really, both of these are using kind of the remainder theorem, but this one, before I skip it and forget to talk about it, there's a question like this. It says use synthetic substitution, which means use synthetic division to find the height at point 8. I wouldn't do that. What would you do? Plug in point 8 and find the height? Everybody okay?
Yeah.
It's not a trick question, okay? Well, you would do 0.8 and then do synthetic. Okay. Use.
It says substitution. That would indicate me to plug it in.
Use the remainder theorem to find the remainder when this is divided by x plus 2. This is the kind of question that's on there, okay? I'm going to do it as it's written in a minute, and then I'm going to talk about why you want to do this. Well, no, I'm going to do that first. I've changed my mind. If this said 2x to the 6th, does anybody want to actually do the synthetic division? You'd have -2, you'd have a 2 with an x to the 6th, no x to the 5th, no x to the 4th, no x to the 3rd, 1x squared, a 3x, and a -6. I'm pretty sure I could mess that up along the way. How else would you do this to find if this is a factor? You don't want to actually divide it, right? What are you going to do instead? Plug in what?
The 0.
Which is -2. So you would do 2 times -2 to the 6th plus -2 squared plus 3 times -2, 6. Oh, this was a 6th, yeah. Okay. I'm pretty sure that's not 0 because I'm thinking this is going to be a pretty big number that this is not going to get rid of, right? So you would, whatever you get would be the remainder. Somebody want to really find that or not?
76. Let's just say that. It's gonna be way bigger than that.
-8. It's 2 to the 7th minus 8, whatever that is. All right, so is this a factor? What we got when we plugged it in, it should be the same thing we would get as a remainder. That's what the remainder theorem says. Nobody found it? It's 120.
I was so close to that 76.
So is this a factor, guys? No. Now, if I went back and did this, and I'm not sure this works, but let's try this. If I made it an x minus 2, what would you do then? Positive 2, and I changed the whole question. Remember, it was 2 times 2 to the 3rd plus 2 squared plus 3 times 2 minus 6. That's not a 0 either, though, is it?
Probably not.
I think it's 20. So you would still have a remainder of 20. You'd say, how would you get a yes? If what would your remainder be that would tell you it was yes? Okay. Moving on. Just graph it. It's the answer to everything. Just graph it.
That usually works.
All right. This is just reviewing that, remember to find the possible rational zeros. It's the factors of the constant over the factors of the leading coefficient. Everybody good? Remember this? We'll do an example of this in a minute. Yes? You got to list them? Okay. Sign chart, we're going to do an example off the review of that in a second. All right. I'm going to skip those two questions. Let's talk about this number 17. It says, let me take a picture and make it bigger. Here, let me do this. It's not as bad as it looks. I'm going to take a picture of all of this. Let's get 20 out of the way first. Number 20, what would you do first? Add the 1. And then some of you got really confused. When you have a square root, you just square both sides. When you have a fourth root, you do both sides to the fourth power, not the 1/4. It's already the 1/4, okay? So we would do 4 to the 4th over here, and then we'd have left x squared plus 31. So it's like x squared plus 31 equals 256, subtract square root, blah, blah, blah. We okay? I'm not going to do it. All right, what about this other one? Plus or minus it would be on that one, but it's not that way on the test. So yes, you want to move that 4 over, guys. Please be with me here. Then what? Okay, what happens when we square both sides? Because this is where we all fall down.
You gotta FOIL it out.
Yeah. It's 2x minus 4 times 2x minus 4, which is 2x times 2x, 4x squared. Negative 8x and negative 8x is negative 16x. Negative 4 times negative 4 is plus 16. Good job, Bessie. All right. We didn't get rid of the squared, so we have to factor. It's 4x squared minus 23x plus 28 equals 0. I know I'm going fast. It would take you a lot longer to do this probably, but I'm just faking my way through it here, okay? Minus 16 and minus 7 is 23. Okay, so there's the factors. What does that make the solution? Okay. What's the important thing? When you square both sides, you often get extraneous solutions. All right, if I put a 4 back in here, I get 8 equals 4 plus the square root of, what's 28 minus 12 would be 16. Does that seem okay? 4 plus the square root of 16 would be 4, that's 8. Okay, I need somebody with a calculator. 2 times 7 divided by 4. 3.5, right? Now do 7 times 7 over 4 minus 12. What do you get? 0.25. Okay, and then you square root it and you get 1/2. Okay, so we have 4 plus 1/2. What are you thinking?
4 plus 1/2 is not equal to 3.
Okay. So you have to be really careful on these, okay?
Gotta put another line in it just to be sure.
Yes. All right. Moving on. End behavior, factoring something that's a fourth. Are we okay on that? X to the 4th minus 10x squared plus 9 would factor x squared minus 9. X squared minus 1. Are we done? X plus 3, x minus 3, x plus 1, x minus 1. So we can find all 4 zeros. Number 30 has what? 25. If you took out an x, you'd have x squared minus 7x plus 12 and minus 3 minus 4. You good? This one has number 30. I don't know if you can see this, guys. It's x minus 5 squared and x minus 1 squared. So it has a 0 at 1 and it has a 0 at 5. What degree is it? 4. What does the fact that those are both squared tell us? Okay. Positive leading coefficient degree 4. What's the end behavior? Yes. So it's doing some WE thing, right? Okay. I am going to next talk about list of possible rational zeros. You know what? I'm not. I'm going to go to the one that I have like that. Just kidding! All right. I want to talk about this question right here. Do I need to make it bigger? It's the only one I'm going to talk about, so let me make this really big and just talk about that one, okay? Can you see it now? The top has a 0 at -1. The bottom says 12x plus 6, which would have a 0 at -1/2. All right. Am I okay, everybody? And it also has a factor that says this would have a 0 at -4/3. This is solving an inequality, which I'm going to change to just a greater than, because it wouldn't be on the test a greater than or equal to. I promised you. Now, can you put those in order? Do you remember when we did these, you have to set the top and bottom equal to 0, and you have to do the little sign chart. Okay, yes, and we couldn't find numbers in between. -1.3 something, then -1, then -1/2, which would be 0.5. Okay, think hard. What's to the left of -1.3?
2. -2.
What's between -1.3 and -1? 1.5, no, that'd be to the left. Between 1.3 and 1 was 1.1, 1.2. Okay, between -1 and -0.5.
1.25.
No. Negative
Oh!
0.4. Negative 0.2.
I heard so many wrong answers, I'm frightened. Okay. Above here would be 0.
We can do that one.
If we tested on our calculator, these would be positive, these would be negative, these would be negative, positive out here. So what is the answer in interval notation for where this is greater than 0?
-4/3 to -1.
And then -1/2 to
Infinity.
Whew. Okay.
You know, words grace too.
I like this unit.
All right. I'm going to try to get a couple more questions done. Remember, my clock is fast. We have almost 5 minutes left. There is a question where you have to use your calculator to find a regression equation, okay? Now, I will tell you, I narrowed it down to 2 things. It might say choose a cubic or a quadratic, or it might say choose a linear or a power. I hope those are very clear choices. Can you tell the difference between that shape and that shape?
No.
Can you tell the difference between that shape and this shape?
Yeah, I
Okay.
really can't.
Because what I didn't do is say quadratic or power, because those can be hard to tell, right? Those are more similar, or a quadratic and a quartic, which are basically the same, okay? Unless it's got W shape. So I narrowed it down to 2, and you have to choose which is appropriate based on looking at the scatter plot. Does that make sense? So you're going to plot the scatter plot, and it's either going to look like this or this. You're going to go, oh, it looks like this, so therefore I'm going to do the quad or the cubic regression. It says use the regression, and it says use either cubic or quadratic or whatever. All right. This question is on the test.
This exact one.
Shar is making a box out of this.
Yeah, why does Char need a box? Why doesn't he just go buy a box from the store?
This is 24 inches. This is 18 inches. Last time I used my daughter's name in a question. It's not how she spells it anyway, but her name is Charlie. Okay. 24 inches, 18 inches. She's cutting out little squares that are X by X. Yeah, because she's a math teacher's daughter, so she has to do stupid things. No. All right. So this height is X. Are we all okay on that part?
Yeah.
Okay. Now, this was 18, but she cut X out from each corner, guys.
That was kind of creepy.
And this was 24, and she cut X off each end. All you have to do is write the volume expression, and you're done, okay? You don't have to find when is the volume exactly, blah, blah, blah. Okay, so easy question for the test, actually, right?
Yeah.
Okay, tomorrow we need to go over this question and this question before we start talking about logs. Don't let me forget, okay?
Gotcha.
We have 2 important things to do tomorrow.